In this video, I'll show you how to solve the ALEKS problem called deducing the ions in a binary ionic compound from its empirical formula. To solve this problem, we're going to want to consult a periodic table. Our goal is to figure out the cation and the anion that is in each one of these ionic compounds, and the real trick here is figuring out the charge on each one of these cations and anions. So having a periodic table handy is good because the periodic table shows us which substances have predictable charges, and I'm just going to fill that in on this periodic table as we go from left to right across the different rows or columns on the periodic table. We have all of our +1 elements, and then our +2 elements, and then our +3. These guys don't tend to form ions, and then we have a -3, -2, -1, and again another batch that doesn't form ions. These elements right here are unpredictable, so they all form an unpredictable charge, meaning that we're not going to be able to just make a guess about what the charge is on any of these cations. We're going to have to figure it out. So for the first example, you can see NaCl, and if we were trying to figure out the cation and the anion, remember that in these molecular formulas, we always put the cation first, and then we follow that up with the anion. So the cation is always going to be the first compound in the formula. And to figure out the charge on the sodium, we can see that it's in the +1 column. On the chloride ion, we can see that it's in the -1 column. So it's as easy as that. Let's try our next one. So for the next example, we know that our cation is the cobalt. We know that our anion is the oxygen because cobalt comes first and the oxygen comes second. The cobalt is right here, so that means it is in an area where the charge is unpredictable, so we're going to have to figure out what its charge is. Oxygen is right here, and oxygen is predictable. It has a 2- charge. So how are we going to use this information to figure out the charge on the cobalt? Remember, when cations and anions come together, they do so in a way that results in an overall compound that has no charge at all. So that means that the charge on the cobalt is perfectly balancing the charge on the oxide ions, and that means that it must be a 2+ charge. They're perfectly balanced so that overall this compound is neutral. Let's try our next example. We have copper chloride, CuCl. Copper, here it is, again in the area of unpredictable charges, so we don't know exactly what its charge might be. Our anion chloride over here is in the -1 column, so this is where we have all of our -1 ions, so this is going to be -1. And again, how are we going to figure out the charge on this copper? Keep in mind that the charge of the cations and the charge of the anions need to balance out. So if this is a -1 charge, this needs to be a +1 charge. Here's our next example. We have FeBr3, Fe iron, another one in the unpredictable charge area. Bromide right here in a -1 charge. So that means our bromide is a -1. Now, let me back up for a second. This is a really common mistake that students make. So they see, okay, my cation is Fe, and then my anion is Br3. A lot of students make this mistake. This little 3 right here is indicating the amount of bromines that you have. It's not the formula of the bromine. It's just saying, that little 3 is just saying that there are 3 bromides. You should not have that over here in this answer. The anion is Br, and the little 3 is telling us that there are 3 bromines. It's not Br3, it is 3Br. But in this particular problem, the 3 doesn't belong anywhere over here at all. It doesn't belong anywhere. So our bromide is in the -1 column. That means it's a -1. Now we're going to have to be kind of careful when we're figuring this out. What is the charge on the iron? We have Fe, we don't know what its charge is. We have Br-. Remember that we have 3 of them. So all together they have a 3- charge when you add them all up. And that means that our iron needs to have a 3+ charge to balance them up. Last but not least, we have Au, that's gold, right here in an unpredictable charge area. We have F, that is in a -1 charge. Remember, that little 3 doesn't belong. It's just F with a -1 charge. That 3 is just there telling us how many fluorides we have. Really similar to the FeBr3 problem. So that we know that this must be an Au3+.